Hey guys, my name is Frank, and this is the Python programming video log. Today, I'm going to be making a 3D star field from scratch. Shout out to this person who suggested it. It was an awesome suggestion, and it was really fun to make. So stick around and watch me write this from scratch so you guys can understand how to do it in pure HTML5 and JavaScript. Alrighty, so I already defined the HTML for the document and the CSS, which styles the canvas tag. So the canvas is just going to fill up 100% width and height of the screen, and it's going to have a fixed position. I define the canvas tag right here in the body element, and let's get to the JavaScript. Alright, so the first thing I'm going to do is get a handle on the canvas drawing context. I'm going to say var context equals document dot query selector canvas, and I'm going to say dot get context 2D. And first thing I'm going to do is draw a black square. So context.fill style equals black. I think that's 6 zeros there. Context.fill rect 0, 0, 100, 100. I'm going to try to draw a 100 by 100 pixel black square. And of course, it's skewed, and the reason that it's skewed from its 100 by 100 aspect ratio is because the canvas is trying to scale to fit the entire window, which it does. As you can see, the canvas fits the inner dimensions of the window, and because its original dimensions are 300 by 150 pixels, that size gets scaled up, and it breaks aspect ratio. So we're going to actually have to change the size of our canvas. So to do that, what I'm going to do is I'm going to come in here. I'm going to say height equals document dot document element dot client height, and var width equals document dot document element with a lowercase l element dot client width. And I'm going to go ahead and I'm going to set the context dot canvas dot height to height and the width to width. And that is going to help us maintain aspect ratio. But since we're not changing the width and height of our canvas on every frame, we're still going to break aspect ratio when we resize the screen. So what I'm going to do is I'm going to create a game loop. Just create a function called loop. And on every frame, I'm going to resize the canvas. And this is also going to be our game loop for the actual project. So kind of is nice, just goes hand in hand. So I'm just going to say window dot request animation frame, hand in the loop function there. So every time the screen's ready to draw, I'm going to call the loop function. I'm going to start off the game loop by calling loop at the bottom of my script there. And I'm going to move this code into my game loop. Alright, so now I'm getting the height and width of the inner dimensions of the document on every frame animation. I'm going to reset the canvas's height and width, and then I'm going to draw that black square as well on every frame of animation. So let's check to see if we have a responsive canvas, and we do. Awesome. So now that I know that my canvas is working right and everything's resizing, I'm just going to go ahead and say fill the entire canvas area with black. And that's going to be the black background for our star field. And great, it works. Cool. I think it works. Oh, wrong thing. Yup, everything works. Everything works great. Catching a peek at my my desktop there. So now I'm going to come not up there, but I'm going to come in here, and I'm going to create a star class. So I'm just going to say const star equals function xyz, because basically the star is just going to be a 3D point. This dot x equals x, this dot y equals y, this dot z equals z, and this dot size, which is going to be the size of our star, equals 25. So star in its natural state is going to be 25 by 25 pixels. And let's see, what else do I have to do? Now I'm going to have to create an array for my stars to live in. So I'm going to say var stars equals new array. And I'm just going to loop through 200 stars and add them to that array. So I'm just going to say for let index equal 0. index is less than 200, index plus plus, stars index equals new star. I'm going to give it a random value between the maximum width and height of the screen there. So math.random times width is going to be my x value. Math.random times height is going to be my y value. And then I'm going to set up a max depth value. So let's go max depth. And that's going to be the maximum distance. 7,500 is going to be the maximum distance my star can be on the z-axis. So the maximum z value one of my stars can have is 7,500, which is pretty deep, I'd say. Pretty deep in a space. So now what I'm going to do is I'm going to position my stars equal distance from each other on the z-axis, and I'm going to do that by saying index times max depth divided by the number of stars I'm creating, so divided by 200. There we go. And actually, since I just have one thing inside of my for loop, I don't even need the brackets. So I'm just going to do that. And that should work. That should create 200 stars. Let's refresh. I don't have any syntax errors, so everything's working good. So now I'm going to come in here inside of my for loop, and I'm going to loop through my stars again. For let index equals stars.length minus 1. Index is greater than -1. Index minus minus. Now the reason I'm looping backwards is because as my stars get closer to me, I'm going to go ahead and just say let star equals stars index star.z minus equals 5. So this is going to bring my stars closer to me, and when they get all the way to 0 on the z-axis, I'm going to have them reset to max depth on the z-axis. So when I do that, what's going to happen is I'm going to have to take my star out of the array of stars, and I'm going to have to put it back into the array. This way I keep my stars sorted on the z-axis, and this is very important. So the reason I'm looping backwards is because when I splice a star out of the array, it changes the length. So I don't have to worry about splicing a star out if I'm looping backwards. I do have to worry about splicing a star out if I'm looping forwards. So that's a brief explanation of why I'm looping backwards there. So what I'm going to do is, before I even get to any of that stuff like z ordering and stuff like that, what I'm going to do is I'm just going to draw my star. So I'm going to say context, there we go, dot fill style equals white. Context.fill rect star.x star.y star.size star.size. Okay, so now when I save, hopefully I don't have any errors here. Clearly there's one right there. Hopefully I get this on the screen. I get just a big group of white rectangles on my screen. Looks kind of lame now because I haven't actually projected any of my 3D stars onto my 2D screen. So the first thing I'm going to do, which is going to be cool, is I'm going to scale the size of my stars. This way it looks like they're actually on a z-axis, and they're actually far away and close to the camera, so to speak. There is no camera object, but close to the screen, close to your eye. Give us a perception of depth here. So first I'm going to define field of view. Field of view is basically just going to be how wide is your field of view, and the width of your field of view is going to determine depth. So field of view, let's just set it for now to be like 500. That's pretty reasonable, I'd say. And let's scale. This is how we're going to scale our objects based on depth. Scale is going to equal field of view divided by field of view plus star.z. So now let's go ahead and come in here and multiply star size by scale. Alright, so they're kind of growing, they're coming at us, but we're not resetting them to the back of the screen, so it looks like they're just filling up the screen. So let's fix that real quick. And this might look like a jumbled mess right now, but actually we're right on track to be creating this. So just bear with me here. It actually does all make sense. I'm going to have to check the Z position of my star and set the star all the way to the maximum depth if it's less than 0. So there we go. I'm going to reposition this. And I'm going to say if star.z is less than 0, star.z equals max depth. Okay. Let's check what that looks like. Alright, very cool, very cool. Now we're going to have to do that projection I was talking about from 3D to 2D. But as you can see, now the stars are gradually getting larger until they come all the way into the foreground and disappear and get reset to the very back. So let's go ahead and do the projection. So let star x equal star.x divided by, what is it, star.z divided by field of view. Star y equal star.y divided by star.z divided by field of view. And we're going to go ahead and plug those values into the drawing function, star underscore x and star underscore y. And now we have a really cool 3D depth effect. The only problem is I want my stars to be in the center of my screen, not all the way up there in the top left corner. So what I'm going to have to do is I'm going to have to define some translation values. So let's go ahead and define those now. Let translate x equal width times 0.5. That's going to be just the center of my screen on the x-axis. Same thing for the y-axis, just with height. Translate y equals height times 0.5. So now I'm going to come in here and I'm going to say star.x minus translate x, star.y minus translate y. There we go. And I'm also going to have to come in here and add translate y and x to the back of this formula right here. So plus translate x plus translate y. And when I save that up, now we actually have some 3D stars coming at us from a depth of 7,500 on the z-axis. So what I was talking about with field of view, if I make this 100, it's going to narrow my field of view, and things are going to seem like they're coming from really, really far away. So right now my eyes are really narrow, really close together, and depth is perceived to be really, really depthy. If I make this something like 1,000, field of view is really wide. Things don't seem so far away anymore. It's not like I got tunnel vision. Things aren't so narrow. I read somewhere that a good way to calculate this is just to get the average of the sum of the width and height of your screen. So what I'm going to do is just that. I'm going to say height plus width times 0.5. And that's going to give us a pretty decent, it looks pretty good. And when you resize your screen, it's actually going to resize appropriately. So that's actually pretty handy. It's a good way to calculate your field of view, just the average of your height and width. At least for me, that seems to be pretty good. So kudos to whoever it was that wrote that on the internet that, you know, helped me out with that. So forget who it was. Feel kind of bad about it right now. But anyway, now let's go about doing some depth ordering. But before I do that, you're not even really seeing the need for depth ordering. So I'm going to actually add color to these stars. The farther away they are, they're going to be darker. The closer they are, they're going to be lighter. So in order to do that, I'm going to use the same scale factor I used for size of the star to get a color based on distance. So I'm going to say let color equal, let's see here, math.floor scale times 256. So that should work. And if I come in here, I'm going to check it. RGB, I'm going to plug these values into the color plus color plus color. Let's see if that worked. All right, definitely worked. The only problem is, and I don't know if you can see this, but the problem is stars in the background are being drawn on top of stars in the foreground. Every so often you can see that happening. Like right there, you can see it. So how do we fix this? This is why I looped backwards. The reason that I loop backwards is because we're going to have to extract stars while we're looping when they get to 0, and we're going to have to place them in the appropriate spot in the array. This way we can maintain a sorted Z order. So what I'm going to do is I'm going to say stars.unshift stars.splice at the index that we're currently at, because the index of the star that we're on, that star is less than 0, so we know we have to splice it out and move it. We're going to splice at that index. We're going to splice out 1, and we're going to unshift that star back into the array in the first position. And I think that's going to fix our problem here. Nope, because clearly stars are still on top of each other. So let's try something a little different. Let's try push. And that looks to be about right, because I don't see any stars on top of each other right now. All right, so that seems to have solved the problem. And just condense this a little bit. Also, what I'm going to do is I'm going to continue. And that's just going to continue the loop. This way we don't actually draw this star. It just gets thrown all the way to the back, and we don't actually draw it. I guess we could draw it, but I'm not going to draw it. So we're just going to continue and skip all this stuff just to be safe, just so we don't draw this star on top of something else. And even though it will be really far in the background, you'll only see it for a split second. We're going to continue just to make sure it doesn't happen. So now we have stars coming at us, and they're changing colors. They're distant and they're dark, and when they get closer, they brighten up. And I think that's pretty much all I want to do for this example. So that's how to make a 3D star field in pure HTML5 and JavaScript. If you guys have any questions on how it was done, please leave those in the comments section. I'll try to get to them as soon as possible. Also, if you have any more suggestions on how to improve my videos or on a video that you might want me to do, definitely leave that as well, and I'll try to get to it. Anyway, thanks for watching, and I'll see you in the next video.